You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. The landscape of privacy and consumer protection is shifting rapidly as regulators look ahead to new areas of risk. Among the most pressing enforcement priorities are the activities of data brokers and the expanding Internet of Things. Data brokers play a largely invisible role in the digital economy, while IoT devices are increasingly embedded in daily life. Both domains raise questions about transparency, security, and fairness that traditional privacy laws were not designed to answer. By analyzing how these sectors operate, regulators seek to address systemic risks before they become entrenched. For learners, this episode emphasizes how enforcement priorities evolve with technological change. Yesterday's focus on cookies and websites has given way to concerns about vast data brokerage networks and smart devices that blend physical and digital environments. The lesson is that compliance strategies must anticipate emerging expectations, not just follow established rules. Data brokers are defined as entities that collect, aggregate, and sell or share personal information, often without direct interaction with the individuals whose data they handle. These brokers act as intermediaries, providing data to advertisers, insurers, employers, and even law enforcement. Their influence extends far beyond consumer awareness, shaping creditworthiness, job opportunities, and targeted messaging in subtle ways. For example, a broker might build a profile of an individual based on browsing activity, purchase history, and geolocation, then sell it to marketing firms. For learners, understanding the data broker ecosystem is critical because it reveals how personal information can circulate without consent or oversight. Enforcement priorities in this area reflect a desire to make the hidden visible, ensuring that consumers regain some measure of control over how their data is traded. The collection channels used by data brokers are diverse and pervasive. They include web tracking technologies such as cookies, pixels, and device fingerprinting, as well as mobile software development kits embedded in third-party apps. Public records, such as property deeds, voter rolls, or court filings, also feed into broker databases. The combination of commercial tracking and official records creates extremely detailed profiles that individuals rarely realize exist. For learners, these collection mechanisms highlight the difficulty of opting out of data brokerage entirely. Even when consumers limit online tracking, public data sources remain. Enforcement interest lies in how these sources are combined, shared, and monetized without meaningful transparency. Regulators see the breadth of collection as both a technical and ethical challenge. Transparency is particularly challenging in the brokered data economy. Most consumers have no direct relationship with the entities selling their information, which means they never see a notice, grant consent, or exercise meaningful control. Instead, they encounter the consequences indirectly through targeted advertising, insurance decisions, or credit evaluations. The opacity undermines traditional accountability models, which assume a visible relationship between company and consumer. For learners, the absence of transparency is itself a harm because it strips individuals of agency. Enforcement priorities in this space seek to force disclosure, provide opt-out mechanisms, and make data flows more understandable. The broader lesson is that privacy protections require visibility. Without it, consumers cannot act as informed participants in the digital marketplace. Sensitive categories of information handled by data brokers add urgency to enforcement. Brokers often collect or infer data about health status, precise location, or children's activities information that carries heightened risks. For example, location data might reveal frequent visits to medical facilities, while inferences about financial distress could affect eligibility for services. When such sensitive categories are commoditized, harms escalate quickly, including discrimination, stalking, or exploitation. For learners, the handling of sensitive categories shows how regulators prioritize risk. The more intimate or consequential the information, the higher the expectations for care. Data brokers dealing in sensitive categories face particular scrutiny, with enforcement designed to limit potential abuses. Large brokered datasets also raise the risk of re-identification. Even when brokers claim to anonymize or aggregate data, the richness of modern datasets often allows identities to be reconstructed by cross-referencing fields. For example, combining zip code, birth date, and gender can uniquely identify many individuals. When datasets contain thousands of variables, the likelihood of re-identification increases exponentially. For learners, this demonstrates why regulators remain skeptical of de-identification claims in the brokered data context. The sheer concentration of information makes re-identification more of a probability than a theoretical concern. Enforcement efforts focus on preventing misuse of supposedly anonymous data and ensuring stronger safeguards around aggregation. In response to these risks, state-level trends have emerged targeting data brokers with registration, disclosure, and opt-out requirements. Laws in states like California and Vermont require brokers to register with authorities, publish details about their data practices, and offer consumers mechanisms to opt out of sales. These measures reflect growing frustration with federal inaction and an effort to bring sunlight into an opaque industry. For learners, state-level developments illustrate the patchwork nature of U.S. privacy regulation. Companies must track and comply with diverse requirements, while regulators experiment with different models to hold brokers accountable. The takeaway is that data brokers cannot operate invisibly anymore, at least not without legal challenge. The Internet of Things adds another dimension to future enforcement priorities. Defined broadly, IoT encompasses network devices that embed sensors, software, and connectivity into everyday objects. From smart thermostats and wearable fitness trackers to industrial sensors and connected vehicles, IoT creates new data flows that blur the line between physical and digital life. These devices often generate constant streams of telemetry that can reveal intimate details of behavior and environment. For learners, IoT represents a shift from user-initiated data sharing to passive, ambient collection. Regulators see this as a fundamental change in privacy dynamics, demanding new safeguards to protect consumers in environments they cannot easily monitor or control. IoT data flows span home, industrial, medical, and vehicle environments, each with distinct risks. In homes, smart speakers and appliances capture conversations and usage patterns. In healthcare, connected devices monitor vital signs or medication adherence, generating sensitive medical data outside traditional HIPAA protections. Industrial IoT systems control critical infrastructure, where security failures can cascade into broad operational disruptions. Vehicles now function as data platforms, tracking location, driver behavior, and even biometric indicators of fatigue. For learners, these diverse contexts show why regulators are treating IoT as a priority. The same core principles: security, minimization, and transparency apply, but the stakes differ dramatically depending on whether the data involves consumer habits, patient health, or critical infrastructure. One major challenge with IoT is the life cycle of devices, particularly updates, patching, and end-of-support concerns. Unlike software applications that update automatically, IoT devices may remain in homes or businesses for years without security updates. Once support ends, vulnerabilities remain unpatched, exposing users to long-term risks. Regulators view failure to provide reasonable patching mechanisms as an unfair practice, since consumers cannot reasonably avoid the risk themselves. For learners, the long-lived nature of IoT devices illustrates why lifecycle planning is critical. Security cannot be an afterthought. It must be designed for the entire expected lifespan of the product, with clear policies for updates and eventual retirement. Default credentials and insecure services are among the most visible IoT weaknesses. Devices shipped with factory-set usernames and passwords that cannot be changed create massive vulnerabilities. Insecure remote access services, open ports, and weak cryptographic implementations add further exposure. For learners, these defaults illustrate how design decisions create systemic risks. Regulators view such practices as unreasonable because they fail to provide even basic protections. From a compliance perspective, eliminating insecure defaults is one of the simplest yet most impactful steps an organization can take. It is a baseline expectation, not an advanced safeguard. Privacy-preserving patterns are also emerging for IoT, such as telemetry minimization and local processing. Instead of sending all data to the cloud, devices can process information locally, transmitting only what is necessary. For example, a smart camera might analyze footage for motion locally and transmit only alerts rather than streaming video continuously. This reduces the exposure of raw data and aligns with minimization principles. For learners, these design strategies show how compliance can coexist with functionality. By adopting architectures that limit unnecessary data flows, companies can reduce both regulatory risk and consumer mistrust, creating a more sustainable IoT ecosystem. IoT also introduces safety-critical scenarios, where security failures translate directly into physical harm. A vulnerability in a connected pacemaker, vehicle system, or industrial control sensor can cause injuries or widespread disruption. Regulators frame such failures not only as unfair practices, but also as public safety concerns. For learners, this underscores that privacy and security are not abstract legal constructs. In IoT, inadequate safeguards can cross into life-or-death consequences, elevating the urgency of enforcement. Security becomes inseparable from safety, and compliance failures carry human costs in addition to regulatory penalties. Children's connected devices highlight another sensitive area. Toys, learning tablets, or wearable trackers designed for young users often collect voice recordings, geolocation, or other personal data. When these products fail to implement strong parental controls, meaningful consent, and secure storage, they fall afoul of both COPPA and Section 5 standards. For learners, children's IoT illustrates how multiple regulatory frameworks intersect. Companies in this space must meet heightened expectations, since both the vulnerability of the population and the sensitivity of the data demand extra diligence. Compliance failures here often draw not only penalties but also heightened public outrage. Finally, IoT ecosystems often depend on third-party components and supply chains. A smart device may integrate software libraries, cloud services, and hardware modules from multiple vendors. Weaknesses in any of these links can compromise the overall system. Regulators increasingly expect companies to vet suppliers, enforce contractual obligations, and monitor third-party security. For learners, this emphasizes the theme of shared accountability. Compliance cannot stop at the device manufacturer, it must extend through the supply chain. IoT illustrates vividly how interconnected risks demand interconnected oversight, requiring companies to treat third-party diligence as an integral part of product design and lifecycle management. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Artificial intelligence, broadly defined, refers to systems capable of performing tasks that would ordinarily require human intelligence, such as pattern recognition, natural language processing, and decision-making. These systems are increasingly embedded in consumer services, enterprise operations, and government functions, creating both opportunities and risks. For regulators, the central concern is that AI systems can amplify existing biases, operate without transparency, and process massive amounts of sensitive data. A loan approval algorithm, for example, may deliver decisions with profound consequences, but offer little explanation of how it reached its conclusion. For learners, the emergence of AI as an enforcement priority underscores that privacy and fairness are intertwined. Regulation is moving toward ensuring that AI does not simply function efficiently, but also responsibly, with safeguards that align with long-standing consumer protection principles such as honesty, reasonableness, and respect for autonomy. Training data governance is a foundational issue in AI oversight. The quality and fairness of outputs depend directly on the provenance, licensing, and representational coverage of input data. If training sets are skewed towards certain demographics or collected without proper consent, the resulting models inherit those flaws. Regulators emphasize that data used to train models must be lawfully sourced, sufficiently representative, and properly documented. For example, building a facial recognition model using datasets scraped from social media without notice or consent risks both legal liability and ethical criticism. For learners, the key lesson is that governance must begin before algorithms are trained. Transparency about data sources and respect for licensing rights form the bedrock of trustworthy AI systems. A major priority in AI enforcement is ensuring fairness and mitigating bias in automated decision-making. Systems that influence access to housing, employment, healthcare, or financial services carry especially high stakes. Regulators expect companies to conduct impact assessments that measure disparate outcomes across demographic groups and to implement bias mitigation techniques when inequities are identified. For instance, an AI-driven hiring tool that favors male candidates over equally qualified female candidates represents a discriminatory outcome that regulators may deem unfair. For learners, this illustrates how fairness is not an abstract value, but a measurable standard. By embedding bias testing into model lifecycle management, organizations demonstrate accountability and align their systems with regulatory expectations. Transparency and explainability are also critical. Regulators increasingly insist that companies document how models function, what assumptions they embed, and how decisions can be explained to affected individuals. Documentation is not just for engineers but for auditors, regulators, and consumers who may demand insight into automated outcomes. Consider a consumer denied credit by an algorithm. Transparency requires that the company explain the relevant factors rather than hiding behind black box complexity. For learners, explainability shows how enforcement priorities are pushing AI toward accountability. Transparency is not simply a technical challenge but a governance requirement, ensuring that decisions are open to review, challenge, and correction when necessary. Data minimization and purpose limitation apply as much to AI as to traditional data processing. Training and inference pipelines should be designed to use only the information necessary for the intended purpose. Storing vast amounts of unrelated data simply because it might be useful later conflicts with these principles. For example, a predictive text model may not need to ingest detailed location data to function effectively. Regulators emphasize that limiting input data reduces both compliance risk and consumer mistrust. For learners, minimization and purpose limitation highlight the continuity between AI and broader privacy frameworks. New technologies do not erase fundamental obligations to align collection with purpose and avoid unjustified hoarding. Human-in-the-loop review is another expectation for consequential automated decisions. Regulators caution against delegating life-altering outcomes entirely to machines. Systems influencing areas like healthcare treatment or credit approval should allow for escalation to human review, ensuring that anomalies or errors can be corrected. This hybrid model provides both efficiency and fairness, combining algorithmic speed with human judgment. For learners, human-in-the-loop design represents a safeguard against the brittleness of automated systems. It acknowledges that even the most advanced models can misfire, and that ethical responsibility requires a mechanism for human intervention when stakes are high. To reduce privacy risks, AI development increasingly employs techniques such as synthetic data, pseudonymization, and privacy-preserving learning. Synthetic datasets mimic the statistical properties of real data without exposing individual records. Pseudonymization reduces linkability of data to specific individuals. Privacy-preserving methods, such as federated learning or differential privacy, allow models to train on decentralized data without centralizing sensitive information. For learners, these innovations illustrate how technology can be part of the solution. By designing AI systems that protect privacy by default, companies can align innovation with compliance, reducing both regulatory exposure and consumer mistrust. Biometric data represents another emerging enforcement priority. Defined broadly, biometrics include fingerprints, facial templates, iris scans, voice prints, and even gait patterns. These identifiers are unique, persistent, and often irreplaceable, meaning their misuse carries permanent consequences. Regulators treat biometric data as especially sensitive, requiring explicit notice, meaningful consent, and strict controls around retention. For example, an employer collecting fingerprints for timekeeping must clearly disclose the purpose, obtain consent, and establish a deletion schedule. For learners, biometrics underscore why regulators prioritize certain categories of data. When information cannot be revoked or changed, the stakes of misuse escalate dramatically. Security is particularly critical in biometric systems. Liveness detection, spoofing resistance, and protections against presentation attacks are required to prevent fraud. Without such safeguards, attackers could use photos, recordings, or 3D masks to trick authentication systems. Regulators also expect secure template storage, encryption, and strong key management to prevent breaches. Role-based access, audit logging, and segregation of biometric identifiers further ensure that only authorized personnel can interact with these sensitive records. For learners, these technical controls demonstrate how legal obligations intersect with engineering practices. Compliance requires not only consent and notice but also robust technical architectures to safeguard data integrity. Vendors providing biometric software kits or cloud-based matching services also face obligations. Regulators expect these vendors to ensure that their products support compliant use, and that contracts bind operators to proper consent, retention, and security practices. Companies cannot outsource responsibility by claiming that misuse rests with customers. For learners, vendor obligations highlight the theme of shared accountability across digital ecosystems. Whether in AI, IoT, or biometrics, regulators insist that both providers and implementers bear responsibility for ensuring lawful use of sensitive technologies. Across all these domains, enforcement signals converge. Regulators consistently emphasize transparency, minimization, fairness, consent, and secure operation as non-negotiable principles. Whether dealing with data brokers who trade in hidden datasets, IoT devices that collect constant telemetry, AI systems that shape life outcomes, or biometric technologies that authenticate identity, the expectations align. For learners, this convergence provides clarity. The specifics may differ by sector, but the underlying values remain steady. Companies that embrace these principles proactively will be better positioned to navigate future enforcement and build consumer trust. In conclusion, future enforcement priorities illustrate how regulators adapt to technological change while remaining anchored in enduring values of honesty, fairness, and accountability. Data brokers, IoT, AI, and biometrics each pose unique challenges, but they are united by the potential for harm if left unchecked. By emphasizing transparency, minimization, fairness, consent, and secure operation, regulators aim to create a digital ecosystem that empowers consumers and restrains misuse. For learners, the message is clear. Compliance is not only about avoiding penalties, but about embedding these principles into the design of systems and services. This forward-looking perspective ensures resilience in the face of innovation and trust in the evolving digital landscape. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.